Hello there and welcome to A2 Maths. We're on Specimen Paper 1 and here we're looking at question 2, a binomial expansion question. So show that the binomial expansion of 4 plus 5x to the power of a half in ascending powers of x up to and including the x squared term is this expression here, giving the value of constant k as a simplified fraction. So let's just remind ourselves what type of binomial expansion we're probably going to be using here. We've got a power of a half, so we have to use this expression here. It's going to be 1 plus nx plus n bracket n minus 1 over 2x squared plus dot 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 dot. Now what we have here is 4 plus 5x to the power of a half. So we definitely know that n is going to be a half, but we haven't got a 1 at the front of our bracket. So what we need to do effectively is to now factorize out 4 from the brackets. Now what we do when we factorize 4 out of the bracket is that the power of the half needs to go with it. So it's now going to become 1 plus, so we've factorized out the 4. Now if we factorize 4 out of 5, we're left with 5 out of 4. So it's going to be 5 out of 4x to the power of a half. So that's how you will split up this expression here to leave you with a 1 at the front of your binomial expansion. So therefore it's going to be 2 brackets 1 plus 5 over 4x to the power of a half. So we'll just put a 2 at the front of our bracket and we'll expand it later on. Now, in our binomial expansion formula here, we're going to have n as the value 1/2, and x is going to be represented with 5 over 4x. So wherever we have an x in our formula, it's going to be represented with 5 over 4x. So let's now use the binomial expansion formula. So it's going to be 1 plus n, which is the value 1/2, x, which is the value 5 over 4x. So that's the second part done. Now moving on to the third part, it's going to be 1/2. n minus 1, that's now going to be minus 1/2 over 2 times by 5 over 4x. And that's all going to be squared. A classic mistake here would just be to do 5 over 4x squared. Rather, it's the 5 over 4x that needs to be in brackets, and then the whole of that needs to be squared. Let's now expand the brackets and simplify. It's going to be 2 times 1, that's 2. 2 times 5 over 8, that's going to be 5 over 4x. That's just as we were expecting it to be. And now we need to be careful on the last one. It's going to be negative because we've got half times minus a half. So it's going to be a half times minus a half divided by 2. So that's already minus 1/8 divided by, times by 5 over 4 squared. So that's going to be 25 over 64 x squared, and that's it as a simplified fraction. K is equal to 25 over 64. Whoops, it needs a minus sign there in front of it as well. So there we are, that's the answer to part A then. Let's have a go at part B. Using your expansion from part A with the value x equals 10 to find an approximate value for the square root of 2. Give your answer in the form p over q, where p and q are integers. Let's just rewrite out what we had from part 1. So it's 4 plus 5x to the power of a half equals 2 plus 5 over 4x minus 25 over 64 x squared. Okay, now I'm thinking, well, how is 1 over 10 substituted in going to give me an approximate value for the square root of 2? Let's start putting 1 over 10 in on the left-hand side first. So it's going to be 4 plus 5 times 1/10, that's going to be 1/2, because it's 5/10. And then add these two things together, we're going to get 8 over 10, that's going to be 9 over 2 to the power of a half. So that's then going to be, is that right, 9 over 2? Yeah, that's definitely right. So it's therefore going to be 3 over root 2 when we do the half inside there. And then let's rationalise the denominator, so it's going to be 3 root 2 over 2. Okay, so what we're going to do then is once we've substituted in 1 over 10 into the right hand side, we need to double it and then divide it by 3 to get the square root of 2 on its own. So let's now substitute in 1/10 onto the right hand side, so it's going to be 5 over 4 times 1/10 minus 25 over 64 times 1/10. Now, although this is an approximation question, whoops, that needs to be squared, we can use our calculator here. So let's grab our calculator and now work out what this is going to be. It's going to be 2.121 ... So 2.121 ... 2.121 ... And now what we need to do is we now need to times by 2 and divide by 3, which is then going to give us, as a fraction, when we use our calculator answer button, make sure you do use that because it is asking for a simplified fraction. It's going to be 256 over 181. The fraction that we needed earlier was 543 over 256. So there we are, that's our answer to this question here then. So that's part I done now. Part II, explain why substituting in 1/10 into this binomial expansion leads to a valid approximation. Well, going back to our binomial expansion formula, this works if the modulus of x is less than or equal to 1. We changed it into 5/4, so it's 5/4x needs to be at less than or equal to 1. So because any x value can be substituted in, can be used, as long as the modulus of 5/4x is less than or equal to 1, less than 1, or in other words, if we multiply out the 5/4, then multiply by 4, divide by 5, as long as the modulus of x is less than 4/5, which it definitely is. X equals 1/10 satisfies this. Okay, so there we are. That's the answer to part A and part B there. So 256 over 181, and yeah, 1/10 satisfies modulus of x being less than 4/5. So 1/10 can be used. The smaller that x value is, the more approximate, the more accurate our approximation is going to be. So there we are, that's 8 marks for question 2 then, binomial expansion question. Let's now move on to question 3.